Hello and welcome to the PSV introduction, sizing and selection. So in this lecture, we want to we want to discuss different type of scenarios and if which of this scenario which I have mentioned, I have written down within this slide is applicable within a vessel or equipment that we want to install a PSV is applicable or not. And you will also learn how to calculate relief load within those different scenarios. And additionally, the second part of this PSV lecture, you'll learn how to size a PSV and select the proper PSV for your case. And at the third part of these courses, you want to learn Aspen Solar System Analyzer. But within this lecture, I want to just focus on the block discharge outlet and how we can calculate relief load and check it out if the block outlet or block discharge is applicable within our case or not. I'm not quite sure how many lecture I want to produce or publish. But what I know, this is the first lecture that I want to discuss about the block discharge or block outlet scenario. There we want to check it out if it's applicable within our system or not, and you will also learn how to calculate relief load. A stream pressure is 8 bar and the vapor flow rate is 10,000 kilogram per hour. We have three valve at the outlet of this vessel. You can see there one of valve O, valve 1 or valve 2 is closed, or at most two of those two valve is closed. Is closed or blocked, if this block discharge is applicable just right here or not. There, absolutely it's not, because the vapor pressure is 8 bar, and when it goes into the vessel, it can pressurize the vessel up to 8 bar. Yeah, while the set pressure of the vessel is 10 bar. So this within this for this vessel, in this case, the block discharge is not applicable. If we get back to our inequality, which states maximum operating pressure, which is 8 bar, if it's bigger than 1.1 times design pressure of the vessel, which is 10 bar, this inequality is not satisfied. So according to this simple formula, this is not applicable to install a PSV for the vapor outlet for vessel valve 1 or valve 2. So the block outlet is not applicable within this case. So let's jump into the next slide. If within the same vessel, we have vapor that its flow rate is 12,000 kilogram per hour. It's vapor. Its pressure within the BS stream is 25 bar, and it goes into the vessel, which its set pressure is 10 bar, and we have those three similar valve at the outlet of the vessel. If we get back to our formula, which states maximum operating pressure should be greater than 1.1 times design pressure of the vessel, which is 10 bar. So 25 is bigger than 1.5 times 10 bars. So we should consider install a PS for the vapor outlet. So how to calculate the relief load? So let's consider entrance valve is fully open while valve 2 is fully closed. And the valve 2, let's assume valve 2 can handle up to 12,000 kilogram per hour, while valve 1 can handle up to 10,000 kilogram per hour. So once the BS stream goes into the vessel and its flow rate is 12,000 kilogram per hour and valve 2 is closed, and valve 1 can handle up to 10,000 kilogram per hour. Where should those 2,000 kilogram per hour goes? Yeah, you're right. We should install a PSV for the vapor outlet. So that is the relief load. Relief load equals the amount of vapor that goes into the into the vessel, which is 12,000 kilogram per hour, and valve 2 is closed, and valve 1 can handle up to 10,000 kilogram per hour. That minus 12,000 minus 10,000 equals 2,000 kilogram per hour. So the relief load for this PSV is 2,000 kilogram per hour. So what about the liquid stream? At the bottom of this vessel, as you can see, we have valve 3. If block discharge is applicable for this, valve or not. So consider the same vessel. We have the high and diameter, which is 2 and 1 respectively, and high liquid within this vessel is 0.5 meter. And the liquid volumetric flow is 1 cubic meter per minute. So let's consider this entrance valve is fully open. And valve 3, while also valve 3 is closed completely or blocked. If block outlet is applicable, just right here, we should calculate empty volume for our vessel and then calculate how much time for the liquid takes to goes from the high liquid level, which is the worst level, that how much time does it take from the high liquid level liquid to goes up to the top of the vessel. We should calculate this time. If this time is less than 10 minutes, we should consider or install the PSV for the liquid applet, which is valve 3. So let's calculate empty volume within this vessel. High liquid is 0.5. So empty volume is cross-sectional area of the cycle, which is pi number times 1 squared per 4 times 2, which is the high of the vessel, minus 0.5, which is a high liquid level. That equals 1 point about 2 cubic meter, which is empty space within this vessel when the liquid is at its high liquid level. Okay, and we should consider and we should calculate how much time does it take for the liquid to goes up to top of the vessel, and the times that it takes to goes up is 1.2 cubic meter per the liquid volumetric flow, which is 1 cubic meter per minute. This is about 1.2, right? That's the 1.2 minute is less than 10 minutes. And it means that it takes about 1.2 minutes for the vessel for the liquid to fill the vessel from the high liquid to the top of this vessel. And since this 1.2 minute is less than 10 minutes, we should consider install a PSV for the liquid outlet as well. So that's the liquid outlet block discharge scenario, and the amount of relief load we should consider how much liquid outlet is goes into the solar system, which is 1 cubic meter per minute. Within this case, as you can see. So we have discussed about the different type of block discharge scenario, different type of scenario, how to calculate relief load within this scenario. I will discuss about the fire exposure or the fire scenario, which get classified into two types, wetted and unwetted, within the next tutorial. I hope you're doing well. Have a good time. Bye.